My name is Siemens from Fernwood Developments. I build both single-family spec homes and custom homes. I've been in the business since I was a teenager. It was a family affair. I grew up working for my dad and my uncles. Started right from the bottom as a cleaner and worked my way through carpentry. I'm passionate about both a well-designed home and a structurally sound home, and I work hard to implement both those things. I'm interested in energy efficiency because it is something that's coming down the road with the code, but I'm also concerned about our environment and our planet. And in a small way, we can make our homes more energy efficient, use less of our resources, and I want to be part of that. The owner of a more efficient home will benefit because it's more comfortable to live in, it costs less to operate, and it's generally quieter. This is a pretty typical spec home I've been building lately. It's 4-bedroom upstairs, 2,600 square feet on the top 2 floors, and an unfinished basement. The things I implemented to become more energy efficient have to do with the mechanical systems, the envelope, the insulation, as well as the air tightness. The goal of this home was to achieve step 3 of the energy step code, which will be a minimum code requirement by 2022. And I took this on because I wanted to be prepared for it. I upgraded the insulation in the attic from an R40 to R51, which was pretty straightforward. I have a steep roof pitch, so that wasn't hard to get the space for that. In the walls, I upgraded the bats to an R22, and in the basement, I insulated the entire slab with EPS foam, which is not what I typically do, but it's straightforward application. For the air barrier, I did something a little out of the ordinary in that I put the air barrier on the exterior of the home. Normally that would be on the interior. The poly that we put up on the walls acts as both a vapor barrier and an air barrier, and I split the two. I still put poly inside, but did not make it an air barrier and didn't seal it off. I did that on the exterior. The reason why it's advantageous to do the air barrier on the exterior is there's less penetrations, so it is easier to achieve air tightness. But it is out of the ordinary and it's a different way of doing things, so there was a bit of figuring out to do there. The air tightness target I was trying to achieve for step 3 is 2.5 air changes an hour. And with doing the air barrier on the exterior, I achieved 1.3 air changes an hour, so I overshot it, which I'm happy about. For the mechanical systems in this home, I upgraded the furnace. I put in a more efficient furnace with a motor that uses less electricity, a variable speed motor. And I also put in a tankless hot water system, which for the owner is a big benefit. They usually enjoy that, not having to heat their hot water continually, but only heating their water when they're using it. I also roughed in for a heat pump, as well as a solar conduit for future hot water. In trying to achieve step 3 on this home, none of the elements I incorporated were overly challenging or out of the ordinary. I think the biggest thing was that the first time you do anything, it takes a little more figuring out. After you do it a few times, it becomes more efficient. So there were a few lessons learned with the air barrier. I've never done it on the exterior before. So there was a lot of thinking and figuring things out with my framer, who had to do some of the prep work. Everything else were elements that we typically have done or weren't too difficult to apply. Also, talking to the energy advisor was a big help. They walk you right through all the aspects of it and take out some of the confusion. The energy advisor is a real key player in this whole process. So you start with them from the very beginning and they model your home for you, they look at your plans and tell you what your options are. It really is not a prescriptive program, it's a choose your own adventure. So I had the ability to pick which elements to use to achieve step 3. And I of course would choose the ones that were more cost effective and achieve the same result. One of the biggest mysteries was how the air test was going to go, the blower door test. So one of the things that we do is we bring him in pre-drywall, and he did a blower door test pre-drywall to let me know where I was at and whether I'd be on target for the final air test. If you're failing at the final air test, then you're in trouble. It's very difficult to tighten the house up at that point. The goal of this home was to achieve step 3 of the energy step code, which will be a minimum code requirement everywhere by 2022. And I wanted to be ahead of the curve and ready for that change. One of the goals of this process is to find out how much achieving step 3 would cost. And as I've been tracking the costs, I'm at the end now, I see that it's cost me about 2% on the total compared to what I would typically do on a spec home. Next time I build a step 3 home, I would do things fairly similarly, but I would probably be faster and more efficient at it. This was a process of figuring out. Nothing was too excessively problematic, but I did have to spend more time on the site thinking with my trades and discussing how we were going to carry out the work. One piece of advice I'd give before aiming for higher energy performance would be to connect with an energy advisor. Call them up, get them to do a blower door test, go through that process when you're not under the gun to actually have a really airtight house. See where you're at now and see where the problems are and how you could solve them. One of the key takeaways of this whole process is how much it's a team effort. All of the sub-trades have a specific role to play, and it's my job to communicate to them what the energy goals are and for all of us to be willing to try a new thing.